Hi, Assalamualaikum warahmatullahi wabarakatuh. Tarcahau and Vanika. My name is Nur Atira Dayana binti Zulkifli 271254. So today, our group will present about the application of linear algebra in traffic flow. So, the study of interactions between automobiles, drivers, pedestrians, cyclists, other travelers and infrastructure in order to comprehend and construct an efficient road network with minimal traffic congestion problems is known as traffic flows. The detrimental impacts of traffic congestion on mankind are numerous. These include motorists and passengers wasting time, thereby reducing regional economic health, delays, which may result in late arrival for work, meetings and education, resulting in business loss, disciplinary action or other personal loss. As a result, the application of linear algebra will be primary emphasis of our research, which may be utilized in real-life situations such as traffic flow. To solve the problem quickly, we utilize the Gauss-Jordan elimination approach.
Hi, I'm Kirinia Priya. My matrix number is 272972. So I'm going to talk about the purpose of the study. The major goal of this research is to demonstrate how linear algebra may be used to analyze traffic flow in a road network, as well as how systems of linear equations with many solutions might develop in practice. Not only that, this study will assist in improving traffic flow in places where it has been identified as a problem. Next is the methodology. To ensure the smooth flow of the traffic, two assumptions have been made. Firstly is vehicles entering each intersection should always be equal to the number of vehicles leaving the intersection. Secondly is the streets must all be in one way with the arrows indicating the direction of traffic flow. Next, I'm going to proceed the system of the equations. At Dewan Mozam Shah UUM, traffic in is equal to Z. Traffic out is 30 plus W. Therefore, it is Z equal to 30 plus W. At SCFP UUM, traffic in is Y. Traffic out is 100 plus Z. Therefore, it is Y equal to 100 plus Z. At TISA UUM, traffic in is X plus 50. Traffic out is Y. Therefore, it is X plus 50 is equal to Y. At SPM UUM, traffic in is W plus 80. Traffic out is equal to X. Therefore, W plus 80 is equal to X. That's all from me. Thank you.
Hello, my name is Roshazin binti Maknasid, number matric 264703. Now, I will talk about result. So based from here, we can see that the figure represents a roundabout in UUM. The road are one way in the direction dedicated. So we know that the unit are vehicle per hour. So from the figure, we can see there are 4 directions, which is the first direction show that from roundabout to Dewan Muazzam Shah UUM take about 80 vehicle per hour. Second direction show that from roundabout to Tisa UUM take about 30 vehicle per hour. Third direction show that from roundabout to SBM UUM take about 50 vehicle per hour. And for the last direction show that from roundabout to SEFP UUM take about 100 vehicle per hour. Now we can assume that the number of vehicles entering each intersection is equal to the number of the vehicle leaving the intersection. So, for each intersection, this fact can be shown by an equation, which is the first equation, x plus 50 equal y. Second equation, y equal 100 plus z. Third equation, z equal 30 plus w. As for the last one, fourth equation, w plus 80 equal x. So, this constraint on the traffic are described by the following system of linear equation, which is negative for the first equation, negative x plus y equal 50. Third equation, y minus z equal with 100. That equation z minus w equal 30, and the last equation for equation x minus w equal 80.
Good evening, madam. Nama saya Sim Jihan, meeting number 2C4526. I correct to present solution of gas elimination by using law certain forms. Rule of gas elimination is row 4 should be 0 and column 2 row 2 also should be 0. Okay. Now we first we solve row 2 row 1 by using negative row 1, and then after d becomes 0, we can see this equation have many possible solutions. So we get W equal 15, and then while W equal 15, S will be 130 and Y will be 180 and Z will be 80. Okay, thank you.
Very good morning to you, Doctor. I will be continuing the presentation by explaining the discussion part of our answers. From our n value by using the Gaussian elimination method, we know that the traffic system offers a lot of options, so it can handle most traffic flows. The set of equations utilized in this solution demonstrates that vehicles have an option at crossroads to maintain a smooth traffic flow. Yeah, in essence, they have the power to regulate traffic as a driver when they choose an intersection to go to. If they choose, if majority of the drivers choose into the same intersection, then the traffic congestion will occur just like what our data has presented, where it has the highest traffic flow along the two routes from X to Y. The solution to this problem would be police helpers come and help regulate the flow of traffic when a road has a specifically high traffic flow. They can help manage traffic flow during peak time to ease the congestion along the way. Another interesting discussion would be the specific routes that vehicles or should I say students take. Because there are 80 vehicles, the third equation in the system reveals that Z will have the lowest traffic flow, whereas Y will have the highest. As Y will have the highest. As a result of this, traffic flow will be affected by size, number of lanes, police roadblocks. Vehicles from other junction interchanges to Z should drive carefully in order to reduce congestion. As a result, at least 80 vehicles per hour must be routed between Z and X to keep the traffic flow moving. And at the roundabout in UUM, every junction has an entry and exit. This causes a huge amount of vehicles entering and exiting the roundabout at the same time. However, the amount is not exactly balanced, as the quantity of traffic entering and exit varies from time to time and is not always depictable by pattern. That's all for me.
So for the conclusion is, we can conclude that the Gauss-Jordan elimination approach may be used to determine the number of the vehicles going through a roadway, or in this example, a roundabout. We can offer the anticipated number of vehicles on a one-way street based on our metric method computation. traffic can be regulated and traffic congestion problems can be avoided if the number of vehicles on the road is understood. As a result, it will be demonstrated that applying linear algebra to traffic flows is beneficial. So that's all from me and my friend. Thank you.